Which number should I say? Anyone? No. Okay, come on. Next number 5. 5. Come on. 5 is 4. Number 4.
Yes, 4. Oh, 5. Slowly.
Done.
I will say any number, okay, from 1 to 20. I can say any number. If you have that number in your ticket, you are going to cut or circle it. Clear? Any doubts? Anyone?
Good. It sank in the water because it is a heavy object. Now everybody observe. Heavy object always sink in the water and light object always float on the water. Okay? The water. Now tell me, did it sink or did it float? Float. Can you why? Can you because it is light. Very good.
Why it did not sink inside?
Slide because it is. Yes, it's light.
Because it is very light. Yes, it is very light as compared to the razor. As compared to the razor, it's very light. That is the reason it is floating.
Now I have very small things and one by one I will put. Now what will happen? The things which are light in weight what will happen to that? It will float on the water. Okay? And things which are heavy in weight, okay, will go down, that will sink in water. Okay? So what thing? Okay? This thing again in the glass of water. Now again we will see what is happening. It is not coming down. See, it is not coming down. It is here only. Why it is here only? Because it is very light in weight.
Materials, there are few objects which are heavy and there are few objects which are light. Okay. So when you put the object inside the glass, the thing that floats on the water. Okay. If you see the light object, that is ball and blocks and everything are floating on the water. Can you see that? And coins and all the heavy objects are sinking inside it. It sank inside the water. Why? Because it is heavy. If you put a rock also, it will go and stick on the water, like down on the glass of the water. But there are few objects that will float on the water. Can you see? Did you understood what I am trying to explain you? This is the experiment of heavy and light.
So write any 12 numbers.
From the number, yes, Debbie, listen. From the number 1 till the number 20, you can write any 12 number. Have you have a housey ticket? Any numbers are there, random numbers? So from the number, Debbie, I just told. From the number 1 till the number 20, you can write any number. From the number.
What comes after 60? What comes after 60? What comes after 60? So whatever is the answer, you will cut the answer, okay? What comes after 60? The next one is 3 plus 3. I repeat, 3 plus 3. So whatever is the answer, if it's there in your... The answer is 2. Is number 2 there in your ticket? No? Okay, then don't circle it. If it is there, then circle it. Okay? The next equation is 2 plus 1. I repeat, the next equation is 2 plus 1. What is the answer? The answer is 3. Is number 3 there in your ticket? Yes? Okay, so come on, circle it. If it is not there, then don't circle it. Okay? The next equation is 3 plus 1. Come on, do it on your fingers. 3 plus 1.
What you saw? Yes. Why? Because the lemon is heavier than water. Okay? The lemon is heavier than water. Okay? Everybody? Yes. Now what are we going to do? We are going to take another glass and in that we are going to put salt and stir it. Okay? Now you have to take a pinch of salt and then you have to put inside your glass.
Take another lemon and drop it in the second glass of water.
With slanting down.
What happened?
That you will take a
Anaisha, please mute for 1 second. Anaisha, take the bubbles. Now compare both the glasses. See, in one glass, the lemon.
Take a lemon. Take a lemon. Put it inside. Now is it floating or did it sink? It is floating or did it sink inside? It is floating. Floating. Why? Because now water is little heavier than the lemon. Why? Because we have put salt inside that. Yes, that is the reason. See the previous one. Can you all see the previous one? The lemon sank inside. Why? Because there is no salt inside the water.
Now take the lemon and again put it in the salty water. Now can you all tell me what happened to the lemon? Is it floating or is it sinking? Float. Very good, very good, very good. But can you all tell me the reason why this time it is floating? Can you all tell me why? Because of salt. Very good. Okay.
I am Arabia. I was born in 476 AD in Shumra, Bihar, India.
Arhan?
Who wrote Arya Bhatia when I was 23 years old? I am the man who invented zero and helped the world to solve many issues.
are you ready? Okay, start.
The day I was aware of zero as well as use of large numbers till 1018.
We are ready?
Yes.
Start.
I was the first to calculate the value of pi. That is 3.142 the fourth decimal point, and I searched for its formula of calculating triangle and circle.
Super. Group 1 done, right?
The concept of zero. Let's learn about a value of zero.
Ishan, start.
Zero means none, no, nothing, or no object. It has no value of its own. Who invented zero and helped the world to solve many issues? I was aware of zero as well as the use of large numbers till 1018. I was the first one to calculate the value of pi. That is 3.14 to the fourth decimal point. And I searched for formula of calculating triangles and circles. Zero is taken away from any number.
Good. Very good. Super.
What is zero? Today I am going to teach concept of zero. Let's learn about the value of zero. Zero means nothing or no object. Zero has no value of its own. Number zero is very important in mathematics because zero separates negative numbers from positive numbers. Thank you. Here about some interesting facts. I invented zero as well as discovered many things in maths and faith. Assistant, where sun was in center. Thank you. I invented zero.
I can cut.
I use calculator.
Okay.
And shine because of the light of the sun. Thank you, God. How many days are there in a year? I invented zero as well as discover many things maths and space. Who I was the first person who invented zero. I was the first person who Who calculated the value of pi? Bhatia is Ashwakatantra. My disciple Bhaskara was my work. Aryabhatiya is Ashwakatantra. Hello, I am money. I am defined as anything that people use to buy goods and services. You can buy items using coins and notes. Many countries have own kind of money. Like India has rupees, US has dollars, British has pounds, and so on. So I am a master system, and I come into existence long back in the year 6000 BC. Barter means trading of one thing without using money. Goods are exchanged with another goods, like 6 apples exchange with some rice for some rice. After the barter system ended, I was methods were used to discover its extent. And with the help of methods, I was able. I have a quick way and tell you with a mark of government. Methods that were used to make red, gold, silver, copper. In India, iron, cotton, paita. Later, after India independence, in the year 1947, RBI notes and coins, Government of India. Hi friend, hello. I am digital money. I am people who pay money through online systems. There are credit card, debit card, which are modern means of payment. I help my society to move to cashless payment. I have some apps like Google Pay, UPI, ATM, so on. Thank you. Hello friend. There are interesting facts about me. There are 500 and 1,000 rupees note between the year in 1954 to 1978. 500 and 1,000 rupees note banned in Nepal. Cost of making a 10 rupees coin. making a is 6.10. Apart from Indian English, there are 15 languages that appear on the river side of the road. If you have done not, you can exchange it, it for brand new one from the bank. Our currency and sign note that help blind people to identify the note. Indian currency note that are made cotton and cotton rag. It is not paper, but it feels and it looks paper. Thank you. I hope you enjoyed this project. The process of the moving around between the air and land. Now let me explain the first step of the process in detail. Water evaporates from the sun's heat. Surface of earth because of sun's heat. Water turning from liquid to gas is called evaporation. Evaporation happens from fast on hot days. Now let me take you forward to the second step of this cycle. The second step is called condensation. Condensation is the process of water turning from gas to liquid. The evaporated water cools down to form small droplets of water. In the third step, the water droplets formed during condensation get heavy and fell down back on earth in the form of rain. This process is called precipitation. Precipitation can happen in different ways like rain, snow, and hail. So this entire process is called water cycle. The water we get in the form of rain is very useful. All living things, including human, depend on the water to survive. But water is not only using for survival; it has many different uses. Different uses of water. There are 30 different uses of water. First, domestic uses of water. Second, agriculture uses of water. And third, industrial uses of water. First, domestic uses of water include factory plants, and for cooking, and for washing utensils, and for washing hands, and for making garden. Now, second one is agriculture uses of water includes for watering plants and crops. Now, third one is industrial uses of water includes for cooling, and for processing, and for diluting, and for fabricating of products in industries and factories.
As water is very important for survival and is also useful for many different purposes, we should learn and practice a few ways to save water. The process of saving water is called conservation of water. Here I have few ways to share which will help in water conservation. Close the taps while brushing, fix any leaking taps at home, take quick showers, and collect and store rainwater for later use.
Let me take you forward 2 seconds.
1, Wait.
Experiment is on electrical circuit. The aim of this experiment is to demo a simple electrical circuit to light LED bulb. For this project we are required number one battery, number two LED bulb, number three connecting wire, number four switch. The switch, this is the LED light, this is the battery, and if I put the switch to on, the LED light will turn off, and if I put it to off, it will turn off. Now I will explain the theory. An electric circuit is an enclosed path which around electricity can flow. It includes an battery, which is a source of electricity, and wire, which is an conductor of electricity, and switch that you could off and on the bulb and bulb, which is an appliances of electricity. The all main parts when are secured, the bulb glows. Now I will continue. When the switch is on, the circuit is complete and the electric current flows like the LED. When the switch is off, the circuit breaks. Conclusion is the electric circuit need to be closed to flow the current and light the bulb. And going to speak on Swachh Bharat Abhiyan. This is my Swachh Bharat. Swachh Bharat Abhiyan is a campaign that aims to clean streets and roads of India. Swachh Bharat is a good step undertaken by our Honorable Prime Minister Mr. Narendra Modi. A step of a government to clean India is very appreciable and I owe to contribute to it. It was officially launched on 2nd October 2014. The main objective of Swachh Bharat Abhiyan is to make India open defecation free. I will tell about lake. We should keep lake clean. It is source of water. We should not throw waste in lake. Avoid using harmful chemicals. Use reusable water bottle. Reduce, reuse and recycle should be our motto. Swachh Bharat and Swasth Bharat. Today, my topic is cities. As my friend Ridhan covered Swachh Bharat mission, I will cover Swachh Sarvekhan. The Swachh Sarvekhan was launched in 2016 by the Government of India. They were to identify the cleanest cities in our India. There were two main goals. The first goal was to make India ODS, that means open defecation free. The second goal was to get citizen participation. As you can see in my chart, in 2016, the cleanest city was Mysuru. 2017 till 2020, there was Indore at the first place. I am going to speak about factories and its relevance in hygiene. It causes pollution by using fuels which affects the air we breathe. The solution is we use soil energy, soil and wind energy. Factories also cause water pollution by release of waste in the rivers and lakes. The solution is that The waste can be processed before it is released into the water. Observing proper hygiene standard in terms of hand nails is very important. To introduce myself, I am none other than Dr. Vikram Ammalai Saravad. I was born on 12th August 1990 in Ahmedabad into a family of industrialists. I studied in Gujarat College, later shifted to University of Cambridge in England. Then World War II forced me to return to India. I was a unique combination of industrialist, visionary, scientist. My mother's name is Sarla Devi and my father's name is Ambal. My mother's name is Sarla Devi and my father's name is Ambalal Sarabhai. He is from the famous Sarabhai family of India. From my childhood, I have developed intense love for science. That interest became an obsession in 1940 when I came back to India after my graduation. I married with a classical dancer named Mrinalini in 1942. The study of fire energy were auspicious. There was deployment of highly sophisticated telescopes. So, I, along with my students, set them up in Ahmedabad, Trivandrum, Kodaikanal, and Gulmarg. This study became the most important dynamics of interplanetary space between Earth and Sun. Later, my interest shifted to the study of teachers and my dear friends. Today we will play one game. In this, there are plus, minus, and multiplication. Let's start. So my first question is, dash plus 50 is equals to 170. So what's my answer? 20. Wrong. The answer is 120. Now the second question. 7. Now it's minus. 700 minus dash is equals to 400. 300. Correct. Card and keep it in your mind. You don't have to tell me. Okay. Done? Yes. The hell the number is there in this card? No. In this card? No. In this? No. In this card? Yes. In this? No. 5. The number is 5. Hello, my dear and teachers. With that, can you tell me this is a chat? I will scroll the dice and you have to. I will tell you the number and you have to tell in which color I will put that number. Okay? 6. Where should I put number 6? In which color? Pink. Okay. 16. In the blue. Yellow. Now tell 6.
6, 1, 2 or 5, 6, 6?
6, 1, 2.
Today we are going to learn all about math.
Oh, don't make faces. We'll not teach you math.
We will tell you what is math.
And also how we use math in our day-to-day life without even noticing. Devang, tell me, what is math?
Math is geometry, numbers, figures, shapes, etc. etc.
English teacher always tell us to use dictionary. Let's check what's in there. Mathematics or maths is study of number and how they are related to each other and to the real world. I have also found some more information. Let me tell you about it. People have used mathematics since ancient times. The Egyptians could not have built the pyramids without a very good understanding.
Yes. I've come across this in history too. Ancient Greek and Arab ideas about math eventually spread to Western and Europe. Math progressed as European scientists used it to research other subjects.
Yes, my brother did tell me once. Aryabhatta was the first of the greatest astronomers of the classical age of India who gave the world the digit zero, for which he became immortal. Math is fun sometimes, but boring too. Why do we even need to learn all about math?
But why do we need to learn math? I get so confused when there are so many numbers and places and this and that. Oh God, why math? I love science more.
Do dislike math and love history more. But do you know why maths is important? Mathematical knowledge plays an important role in understanding other school subjects such as science, English, and even music and art.
I don't think so. It is not used in English.
So tell me, how many vowels and consonants are there in alphabet?
5. How did you count? I counted with the help of my fingers. See, 1, 2, 3, 4, and 5. In that case, maths is even used in history. In history, mathematics help in calculation of dates like duration of Britishers ruled in India. It's even used in geography. Latitude and longitude are also numbers, right? I love art, and there is math in arts too. See here, this is an assignment given by my art teacher. This is called mathematical art. Yes, even we are making this math project. It's called shape. We are going to show you how we can make shapes using toothpicks and clay. See how creative. Okay, but that's art and that's fun. How do you solve math in a fun way? We are using it every day in a fun way. Let me show you how.
I would like to buy these apples.
How much do you want?
1 kg.
Wait, I am and calculating money. So, as you buy 1 kg, I will give you some discount. Rather than buying 100, rather than paying me 100 rupees, you can pay me 90 rupees.
Oh, thank you. You're so generous. Here you go.
When we buy something, we measure it. That's math, you see. When we give money for the thing we bought, that is also math. Yes, even when we calculate time. How long does it take for you to reach school custody?
Oh, please don't tell me 5 minutes. Considering opening the laptop and joining through Google Classroom. You mean how we used to go school physically? Oh, I think 20 minutes.
Oh, it is just 10 minutes, Bonnie.
But I still don't understand how we solve math. I like it when we do projects and activities. Yes, me too. I like games. I don't like when we have to write so much text in order to solve just one word problem. I agree with you, Summer. Now I understand what is math. Why do we need math?
We use it every day because math is everywhere. I can show you how little it can be.
Today I'm going to show about mathscope. First, a question, think of a number.
Done.
Step 2, multiply it by 3.
Done.
Step 3, add 6.
Done.
Step 4, divide by 3.
Done.
Step 4, subtract the number chosen in step 1.
Done.
Answer is always 2. What answer you got?
2. How to do fractions? A fraction is a number that is numerator and denominator. So this is a circle. And I have divided into 8 parts. So if I shade one part of the circle, the fraction becomes 1 by 8. If I shade 2 parts of the circle, the fraction becomes 2 by 8. That is 1 by 4. If I shade 3 parts of the circle, the fraction becomes 3 by 8. If I shade 4 parts of the circle, the fraction becomes 4 by 8. That is, half of the circle is shaded. So if I shade the whole by shade 2 parts of the circle, what is the fraction?
2 upon 4.
Excellent. If I shade 3 parts of the circle, what is the fraction?
3 upon 4.
Very good.
We will learn in math in a fun way and in a good way. And you will like it. Let us start. I have a 2 balls. My friend Summer give more 3 balls. How does I have? Yes, I have 5 balls. I have 2 balls. Told me I want more 2 balls. How does ball I have? Yes, I have 0 ball. Now I will give you some numbers, some cards. You have to give me answer. Okay? What is the answer of this? Summer, tell me.
It is 222.
Yes, correct.
I will talk about fraction. Fraction is a tiny or small part of something. We use fraction every day. Let's see how. With pizza, I will show you how. This was a whole 6-slice pizza. I ate 2 slices. Now, David, can you tell me which part of the pizza is missing in fraction?
I have to tell the answer.
Yes.
6 by 4.
Wrong. It's 2 by 6. And we can also say 1 by 3.
Today I am going to show an experiment on water purification. I am from 2B class. My experiment's name is water purifier. So the materials which we will need are cotton, soil, sand, pebbles, and plastic bottle which is cut from the bottom. So, and we will also need 2 glasses, one half filled with water and one empty. Good morning, friends. Good afternoon, friends and teachers. I am Judith Lal. Today I am going to tell about agriculture. Agriculture is the science, the art, cultivating soil and producing crops and raising livestock. In addition to provide raw material and food, agriculture also provide employment opportunity to a very large percentage of population. Now my friend Diana is going to tell about tools, resources and material. Good afternoon, friends and teachers. Today I'm going to tell you about material, resources and tools. Farm tools are instruments used in farm to aid work. My name is Krishna Majithia. I am going to talk about sustainable development of Mumbai. The first one is open garden and space. Mumbai is also known as cement of jungle. And the main thing is stop cutting the trees. Plant more and more trees so we can get oxygen to breathe and have foods. Hello everyone, good afternoon. I have prepared a sustainable city working model. I have focused on our dream city, Mumbai. There are 11 most important parameters about Mumbai's sustainable city. I have chosen only 3 because of the time constraint. First is rainwater harvesting, green and clean energy resource, and best public transport. We all are facing a lot of traffic in Mumbai city. Even the teachers are facing a lot of traffic to get to school. I have become a female scientist who invented a medical syringe. Medical syringe or injections is something we all are afraid of. Do you know who invented this? I am Letitia Gear and I invented medical syringe in 1899. To give a background about myself, I was born in the year 1852 in New York and I have 4 siblings. And I have spent most of my life in New York. Before my invention, a syringe had to be operated using both the hands and it was really difficult. And that is the reason I invented medical syringe that could be used with one hand and containing glass parts. Through this invention, I have tried to make a simple syringe which will change the world and its concept of medical treatment. Health is wealth. You should follow healthy habits. Clean your hands before having a meal. Trim your hair regularly and keep the house clean. We should wash our hands using the hand washing technique. When we are out and we are not at home,
When we cannot wash our hands, we should sanitize. We should wash and cook our fruits and vegetables before we eat them, especially meat. Whenever we sneeze, we should cover our nose. Due to COVID-19, whenever we go out, we should wear a mask.
Healthy food. Healthy food is the food which we Healthy food is the food which has nutrition in the right amount and the right quantity. Healthy foods give us energy to work, play, and think. It also makes our body strong and healthy. There are 5 types of nutrition: fat, protein, minerals, vitamins, and carbohydrates. Along with that, we should drink 8 to 10 glasses of water daily.
Name life on land. Earth. Earth is becoming dirtier nowadays, which causes air pollution. There are many different types of pollution. For example, air pollution, noise pollution, water pollution, land pollution, etc. Now let's explain about global warming. Global warming is nothing but increase in the Earth's temperature. Development is necessary, but it is also necessary to protect our environment. Today, our environment is suffering from major issues like air, water, noise, and land pollution, causing extreme climates. Most of these problems are because of human activities like industrialization and deforestation. So let us all help our planet by recycling waste carefully, planting more trees, and saving energy. So now let us understand about the importance of plantation. The trees are like the lungs of the earth. They give us oxygen for photosynthesis and reduce carbon dioxide from the air. They help preventing floods and soil erosion. They cool our surroundings and beautify them. They also provide fruits and vegetables for us. So now let's focus on the concept of 3 R's: reduce, reuse, and recycle. What to reduce? We can reduce water usage, electricity, and fuel usage. What to reuse? Everyone knows that approximately 100 million bottles are used and discarded every year. Let's make something creative out of those bottles. What to recycle? We can recycle paper and aluminum cans. We can also recycle peels of fruits and vegetables. So all because of our hard work, the earth is now clean and green. Because we planted more trees, we did not waste water. So the water is clean and fresh. We are now breathing fresh air, drinking clean water, and living a happy and healthy life. Save earth, save life. Arogya Setu app. Arogya Setu app is an app to spread awareness of the novel coronavirus outbreak among Indian citizens. The aim of the app is it informs the user about precautionary measures and how to maintain social distancing in the time of global pandemic. It keeps the user informed in case he or she has crossed paths with any COVID-19 positive case within 6 feet proximity. The app also recommends several measures to the user, such as self-assessment test, do's and don'ts amid COVID-19. Now my friend Arush will explain more about the app.
Now I'll explain how to operate Arogya Setu app. Download Arogya Setu app on your phone from official app store. Arogya Setu app is available in 11 Indian languages including English and Hindi. Next, tap the register now button. For Argus to work, you need to turn on Bluetooth and GPS on your phone. Register with your phone number and verify OTP. The app shows a risk level in yellow and green color codes. If you mark it green, which means you're safe. If you mark it yellow, which means you're at a high risk level. The apps give you access to COVID-19 health center in your city.
Why Arogya Setu app? Arogya Setu app uses contact tracing to record details of all the people you may have come in contact with as you go about your normal activities. If any one of them at a later point in time tests positive for COVID-19, you are immediately informed and proactive medical intervention is arranged for you. 5 reasons why Arogya Setu. Protect yourself and the community from COVID-19, precision tracking of the spread of coronavirus, access curated relevant advisory, self-assessment test for infection mitigation, help and support at hand. Now my friend Vari will continue.
Don't go to any concert, malls, weddings, or theaters. Please do maintain social distancing. Please do wear masks. Do take immunity boosters like zinc and vitamin C. Don't shake hands with someone else or outsiders. Please do wash your hands.
Can take needed precautions and protect ourselves and our family from coronavirus.
Will do research on quality of milk and vegetables in India. What is fertilizer? Fertilizer is any substance used to add nutrients to the soil to promote soil fertility and increase plant growth. Nutrition is governed by the Prevention of Food Adulteration Act 1954. The Ministry of Health and Family Welfare has established in the Food Safety and Security Authority of India (FSSAI) in the Food Safety and Security Act. FSSAI has set up an online platform named DART to detect adulteration with rapid test. It helps in checking the quality of various food articles like milk, vegetables, fruits, etc. Types and benefits. Milk is an excellent source of protein and calcium. There are different types of milk. For example, whole milk, from which the cream is removed. Skimmed milk, milk from the cream is not removed. Raw milk, milk from the animal that has not been pasteurized. Animal received milk received from animals is in high calcium, protein, and vitamins. It is good for bone development, rich in protein, reduces risk of obesity, prevents heartburns, fights multiple diseases, helps strong teeth development, and boosts our immune system. Milk like almond, soya, hemp, oat, coconut, etc. also have lots of health benefits. Adulteration of milk reduces the quality of milk and has dangerous health effects. Quality control of milk is important so that it can be consumed. Increased demand and huge market for milk and milk products leads to adulteration for profit. I am Isaac Newton. I was born on 4 January 1643 in Woolsthorpe in England. I am best known for my theory about the law of gravity, but my Principia Mathematica with its 3 laws of motion greatly influenced the Enlightenment in Europe. My native language was English. My subjects of study were light, gravity, color, planet, and calculus. Isaac Newton studied in King's School, Grantham, which taught him Latin, Greek, and mathematics. Then he went to Trinity College for further studies. Isaac Newton, when he saw a rainbow, he made the disk. When he spinned the disk, he saw the white color. And when he saw the white color, he understood that the white colors is only the seven color. Every seven color comes from the sun. Then he wanted to study about the sun. That's why he made the telescope. And now the telescopes are used for seeing planets and stars. Hi Vanchika, where were you yesterday? I was waiting for you to join us for the badminton match. Hello David, I have been to my friend's birthday party. How was it? I enjoyed a lot and the cake was scrumptious. Oh, it seemed to eat the whole cake. No, I only had a part of it. A part of it? It means how much? I didn't understand. I'm confused. This is where we need fractions. David, my friends will help you out to understand fractions. Yes, my dear friends, we will help you in understanding fractions. The word fraction has been derived from the Latin fractus, which means broken. Fraction has been into existence from the Egyptian era, which is known to be one of the oldest civilizations in the world. However, fractions were not regarded as numbers. In fact, they were used to compare the whole numbers with one another. Now let us see what are fractions. This circle is been divided into three equal parts. Three parts to make the whole circle.
The top number, called the numerator, shows how many parts we are representing. The bottom number, called the denominator, shows how many parts make the whole.
An easy way to remember which one is the denominator is to think D for down. Remember, our numerator tells us we are using three parts of the whole and our denominator tells us the four equal parts. Here are some other fractions, 3/4, 6/8 and 3/5. So now we know what fractions are. Rashika, can you tell us where do we use fractions in our day-to-day life? Yes, Ananya, the most common examples of fractions from real life are equal sizes of pizza, fruit, cake, a bar of chocolate, etc. Here are some uses of different fractions in real life. Splitting a bill while eating at a restaurant, calculating the discounted price of an object. Fraction are frequently used to analyze the performance of a particular player and team. When we divide a whole into equal parts, equal part is a fraction of that whole. Example, one pizza is divided into three equal parts. 1/3 part of the pizza is eaten. 2/3 part of a pizza is left. Fraction also represent part of collection. Example, there are total three glasses are empty. So 1/3 of the 1/3 or 1/3. A fraction bar separates numerator and denominator. It is a symbol for division. A fraction is just a number that is written like a division problem. For example, one whole pizza divided by two hungry people.
that is 1 divided by 2, that can also be expressed as 1 by 2 or as 1 upon 2 or as half.
The relation between fraction and decimal is clear when you look at the fraction half. When you divide the numerator by common denominator, you get decimal. That is seen in the following. 1 divided by 2 is equals to 0.5. This relates percentage in the sense of 0.5 point.
Now let us see the correlation between fraction decimals and percentages. Making a fraction into percent is easy as you simply place the percentage over the whole number 100 and then reduce it. So 50% becomes 50 upon 100, which is reduced to 1 upon 2. 50% becomes decimal by then dividing the whole number by a common denominator. 1 upon 2 becomes 2 divided by 1, which equals 0.5. So the relationship between fractions, decimals and percentages is that they are simply different numerical expressions of the same value.
Let us now learn different types of fraction. Types of fraction. Like fraction. Fraction having the same denominator are called like fraction. Unlike fraction. Fraction having different denominators are called unlike fraction. Unit fraction are fraction having numerator as 1 is called a unit fraction. Proper fraction. A, a fraction whose numerator is smaller than its denominator is called a proper fraction. Improper fraction. A fraction whose numerator is greater than or equal to its denominator is called an improper fraction.
A mixed fraction is a form of a fraction which is defined as the ones having a fraction and a whole number.
Equivalent fractions are fractions with same value. Sometimes it is very difficult to find equivalent fractions because the digits used in the fractions are completely different. Half is the same as 3 by 6. Lastly, let us now see the fraction art made by our friends.
Thank you, my dear friends, for helping me in understanding fractions.
My name is Karthik, and today I'm going to talk about existence of human. My topic is past, human past. So, by the way, we all are humans, and we all know that we have a history. People that lived in a family before us a very long time ago are called our family ancestors. Uh, we are we all are a species like animals, uh, and our species is called Homo sapiens. We are from the Hominidae family. Hominidae family means the people who walk on two legs with an straight body. The Hominidae family has some more. Is We are the only Hominidae family because the species that came before us were also from the Homo family only, but they were like a little monkey-ish, and they were Homo erectus and Homo habilis. They both were like big apes. As the time went by, the Homo habilis evolved into Homo erectus, and the Homo erectus evolved into we are we are humans. Now my partner Risha will continue.
Today, my topic is human present. Existence is the ability of an entity to interact with mental or physical reality. The societal living is possible when there are communal harmony and feeling of brotherhood among its members. Compared to before, humans are now very intelligent, creative, and responsible. Now, my friend Aryan will continue.
The future of humans. Future evolution of humans will be more technological process rather than biological process. With the population growth, living with more people is a new condition that humans will have to adapt to. So, technologically, we might have an implant in the brain to remember all the people's names. Same way, we might have implants to improve a person, like an artificial eye with a camera or a regrowable rim. Global warming might also have impact on how humans will look. We might have darker skin because of extra heat and UV radiation. The Big Bang Theory. Meaning, the Big Bang Theory is leading explanation about how the universe began. At its simplest, it says the universe as we know. It started with a small signality, then inflated over the next 13.8 billion years to the cosmos that we know today. The Big Bang is how astronomers explain the way the universe began. It is the idea that the universe began just as single point, then expanded and stretched to grow as large as is right now, and it would still be stretching. The first, second, and third of light, birth of light. In the first and second after the universe began, the surrounding temperature was about 10 billion degrees. Fahrenheit 5.5 billion Celsius according to NASA. The cosmos contained a vast area of fundamental particles such as neutron, electron, and proton. These decay or combined as the universe got cooler. Eastern inflation and charting the start. The universe is not only expanded but getting faster as it inflates. This means that with time, nobody will be able to spot other galaxies from Earth or any other vantage point within our galaxy. Will the universe end? If the universe holds in. Good morning, everyone. Today we are going to present technology in agriculture. Technology in agriculture. While aiming to produce enough food and remain suitable, agriculture is facing significant changes. In the new agriculture era, on GPS variable rate application, steering system, and remote sensing as well as farm management software. The introduction revolutionary changes into farming. In other words, modern farm technology revolutionizes the way in which farmers work. Benefits for our industry and our nation. MHRCs could increase industrial energy efficiency, reduce emission of greenhouse gas and environment pollutant, reduce solid and liquid waste. As a result, the technology could reduce manufacturing cost across all applicable industries.
and produce high value hydrogen. Use of hydrogen, chemical fixation of nitrogen from the air and the harbor ammonia process, hydration of fats and oils, methanol production and hydrodealkylation, hydrocracking and hydrodesulfurization, rocket fuel welding, produce MHRCs will increase industrial energy efficiency, reduce emissions of greenhouse gases and environmental pollutants, reduce solid and liquid waste. As a result, this technology could reduce manufacturing costs across all applicable industries and produces high value hydrogen. Thank you. Hello friends, I am Mishka Choksi from 4C and today I am going to tell you a little about who Dr. Vikram Sarabhai was and about his childhood. Vikram Ambalal Sarabhai was an Indian physicist and industrialist who initiated space research and helped develop nuclear power in India. Sarabhai's name will remain inseparable from India's space program. It was Sarabhai who put India on the international map in the field of space research. He worked in the fields of textiles, pharmaceuticals, nuclear power, electronics, and many other constantly till the end. The most striking aspect of Sarabhai's personality was the range and breadth of his interests and the way in which he transformed his ideas into institutions. Sarabhai was a creative scientist, a successful and forward-looking industrialist, an innovator, a great institution builder, an educationist with a difference, an expert of arts, an entrepreneur of social change, a pioneer in management, and more. His parents were Ambalal Sarabhai and Sarla Devi Sarabhai. He was born on August 12, 1919 in a very wealthy family in Ahmedabad. He spent his childhood in his ancestral home, the Retreat in Ahmedabad. It used to be visited by important people from all walks of life. This played a large role in the development of his personality. He had his early education in Maria Montessori, which was the school started by his mother. He then completed his intermediate science examination from Gujarat College. He went for further studies to Cambridge, UK in 1937, where he obtained his tripos in natural science in 1940. At the outbreak of Second World War, he returned to India and joined the Indian Institute of Science at Bangalore, where he took up research in cosmic rays under the supervision of Dr. C. V. Raman. He published his first research paper titled The Time Distribution of Cosmic Rays in the Proceedings of Indian Academy of Science. Sarabhai's work on cosmic rays during the period 1940 to 45 included the study of the time variations of cosmic rays and Geiger-Muller counters at Bangalore and at high hill stations in Kashmir, Himalayas. After the war, he returned to Cambridge to work for his PhD in cosmic rays physics. In 1947, he was awarded PhD by the Cambridge University for his thesis, Cosmic Rays Investigation in the Tropical Latitudes. He also carried out an accurate measurement of the cross-section for the photofission of U-238 by 6.2 MeV by rays, which formed a part of his PhD thesis. After getting his PhD, he returned to India and continued his research in cosmic rays physics. He left for his heavenly abode on December 30, 1971 in Kovalam, Kerala. Now my friend Ved will continue. As Mishka told you about the birthhood of Vikram Sarabhai, I am going to tell him about his invention. Vikram Sarabhai was known as the father of Indian space program. He launched the first rocket of India. Its name was Aryabhat and it was put in orbit in 1975 from rocket named ISRO, and it was sent from Russian Cosmodrome. And he also set up a Darpan Academy of Performing Art with his
by the famed dancer Miliana Sarabhai. Dr. Vikram Sarabhai was led to be a chairman for launching rockets, and he is known as the Great Indian Visionary. Sarabhai was also responsible for setting up multiple other institutions in the country, including the Physical Research Laboratory (PRL) in short form, Ahmedabad, the Indian Institution of Management (IIM) Ahmedabad, and the Wearable Energy Colatron Project Kolkata, and he even made a nuclear power plant. Thank you.
Everybody, my name is Ashar and today we are here to present our project Food Doctor. As everybody knows, the coronavirus COVID-19 is at its ultimate, and I too am aware that the majority of the world's population is not able to complete their food needs due to the COVID-19 circumstances. And that is why our primary purpose to make Food Doctor was to help those people who don't have time to cook food in their busy lives with all their work streams. A second purpose to make Food Doctor was to deliver food faster and safer. If we deliver food by road, it won't let us serve freshly cooked food in a short span of time.
It serves fast delivery. The drone has a carrier that carries the box. The customer does not have any fear of getting hit by the blades. If any birds, the food doctor is shaped like a hawk to keep birds away from the food. If any birds are daring enough to come near the food doctor, the camera attached to it will show the food doctor what is happening so we can steer the food doctor away from the bird. The same reasoning applies to any obstacles. It also has a tracking device so it can deliver food to your house, which gives us time to control the drone and watch the camera. The food doctor is untouched by human hands.
Foodopter is an aerial delivery service. It has an online app through which you can order our food. You can download the application from app stores or from its website. To order food from its app, we have to type or speak out the food item from where we would like it and any additional requirements. For example, if we want to order salad, mention from where we would like it and if we prefer vegan or nuts free or regular, and finally select the quantity required. Also, if we would like to send food to someone else, we can click the Send My Food button and provide the phone number and address of the person we want to send food to and from where the food needs to be collected. This could either be a restaurant, shop, or from our houses. We can order medical supplies too. This is why Food Opera is one of my favorite apps.
Give a gist of our project. I'll detail it for you. So, our food opter is a lightweight aerial delivery system that delivers food super fast and safely. The pandemic will be gone, but our food opter will continue to deliver fresh and healthy meals to hospitals, offices, schools, or colleges, and at home, and will be best used for emergency services. Footopter delivers within a long range of 5 kilometers. The traveling speed of this device is 30 kilometers per hour. That is, it can travel 1 kilometer in 2 minutes. That's quite fast. It delivers all products instantly or quickly, but also hygienically. It can be used to deliver medical supplies at a time of emergency, helping senior citizens and children whose parents are at work all day long. As it can deliver all kinds of products besides food too, it is cost effective. During this pandemic of novel coronavirus, no one desires that the products are touched by human hands. That is to avoid spreading of COVID-19. And Food Opera serves delivery untouched by hands as it uses AI, that is artificial intelligence, to deliver food.
I am going to talk about cube numbers. A cube number is a number that is the product of three numbers, which are the same. In other words, if you multiply a number by itself and by itself again, the result is a cube. Some examples are 13. 13 multiplied by 13 multiplied by 13 is equals to 2197. 12. 12 multiplied by 12 multiplied by 12 is equals to
1728. And 4 multiplied by 4 multiplied by 4 is equals to 64. Cube numbers can be represented usually as 3D numbers of single unit cubes. To write the mathematical formula for cube numbers, we add a single 3 next to and above the number. For example, as you can see, I have written the number 12 and on the above I have written number 3. Hello, today I and my partner Vanchika are going to show you a working model of LCM. But first, what is LCM, Vanchika? LCM is lowest common multiple. Now my friend Sophie will tell you how our working model works. I am going to show you 5 examples of LCM using yarn on my board. Our first example is 3 and 5. 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12, and 3 fives are 50. 5 ones are 5, 5 twos are 10, 5 threes are 15. The place where the yarn meets the first time is the LCM of the two numbers. As you can see, the first answer is 15.
LCM is known as least common multiple, defined as the least number which is exactly divisible by two or more numbers.
Hello everyone, my name is Sharvi. In this model, we are going to take 3 different numbers and find the LCM.
Hello everyone, my name is David. We will explain how to take the LCM of numbers 3, 4 and 6.
As you can all see, 3 numbers are written on the arrows. Let us take the first number 3 and we'll move our strip by adding the same number to it. We'll move our strip to number 6.
Let's now go to the next number 4. We will repeat the same process by moving the strip, adding the same number to it, and our strip is now at number 8.
Similar process for our third number 6. We will add 6 to it and our third strip will move to number 12.
We have to get all the strips on same number by keep on adding same number, and we will move for the strip forward. So again we'll have 3 to the first strip and we'll move it to number 9.
As you can see, all the strips are on different numbers. So we will continue the process for the second strip by adding the same number 4, and our strip is now at number 12.
Now, as you can see, all the second strip has reached 12 and a third strip is already number 12. So now we shall stop this process for our second and third strip.
Today I am going to speak about rational numbers. In mathematics, a rational number is a number that can be written as a fraction. The set of rational numbers is often represented by the symbol Q, standing for quotient in English. Rational numbers are all real numbers and can be positive or negative. A number that is not rational is called irrational. Most of numbers that people use in everyday life are rational. This includes fraction, integers, and numbers with finite decimal digits. Thank you.
A cube number is a number multiplied by itself 3 times. This cube is also be called a number cube. The symbol is 3. 1's cube is 1 is equal to 1. 2 multiplied by 2 multiplied by 3 is equal to 8. 3 multiplied by 3 multiplied by 3 is equal to 27. Cube numbers up to 10. 1's cube is 1.
2's cube is 8 and 10's cube is 1000. Armstrong numbers. It is that is equal to the sum of cubes of its digit. 153. 1's cube plus 5's cube plus 3's cube is equal to 153. 1 plus 125 plus 27 is equal to 150. Some examples of Armstrong numbers are, and these numbers are very rare, 153, 370 and 407. Thank you.
Yes, ma'am. Hello, everybody. My name is Pearl. Today we are going to see the working model of HCF. Do you know what is HCF? HCF is the highest common factors. Now, let's see the model.
Hello everybody, I am Vrishti. Hello everyone, my name is Hridaya and we are going to show you the working model of HCF. So in this working model, we are going to show you how to find the HCF of some numbers. Example 6 and 10. So we are going to place 6 coins and 10 coins each. Now, as you know that 6 is smaller than 10, so we will subtract 6 coins out of 10. So we are left with 4 coins. But as 6 is bigger than 4, so we will subtract 4 coins from 6. Then we are left with 2. But 4 is bigger than 2, so we will subtract 2 coins from 4. Now we are left with 2 coins each. So as you know, 2 and 2 are equal, so the HCF of 6 and 10 are 2. Thank you.
Everybody, my name is Ashar and today we are here to present our project Food Doctor. As everybody knows, the coronavirus COVID-19 is at its ultimate, and I too am aware that the majority of the world's population is not able to complete their food dreams due to the COVID-19 circumstances. And that is why our primary purpose to make Food Doctor was to help those people who don't have time to cook food in their busy lives with all their work skills. A second purpose to make Food Doctor was to deliver food faster and safer. If we deliver food by road, it won't let us serve freshly cooked food in a short span of time.
Food after goes flying, it serves fast delivery. The drone has a carrier that carries the box. The customer does not have any fear of getting hit by the blades. If any birds, the food after is shaped like a hawk to keep birds away from the food. If any birds are daring enough to come near the food after, the camera attached to it will show the food after what is happening so we can steer the food after away from the bird. The same reasoning applies to any obstacles. It also has a tracking device so it can deliver food to your house, which gives us time to control the drone and watch the camera. The food after is untouched by human hands.
One of my favorite apps is Food Opter. Food Opter is an aerial delivery service. It has an online app through which you can order our food. You can download the application from app stores or from its website. To order food from its app, we have to type or speak out the food item from where we would like it and any additional requirements. For example, if we want to order salad, mention from where we would like it and if we prefer vegan or nuts free or regular, and finally select the quantity required. Also, if we would like to send food to someone else, we can click the send my food button and provide the phone number and address of the person we want to send food to and from where the food needs to be collected. This could either be a restaurant, shop, or from our houses. We can order medical supplies too. This is why Food Opter is one of my favorite apps. Here is the screenshot of an app from my laptop. Here are the options given for the willed food, that is salad. This is the restaurant the customer wants it from. This is the option to send the food. This is where you get to find out about food. This is the reviews of the restaurant. This is this tells what it includes. This is about the price, and this is about the ingredient of a particular item.
Earlier, my friend gave a just a far present. I'll detail it for you. So, our food opter is a lightweight aerial delivery system that delivers food super fast and safely. The pandemic will be gone, but our food opter will continue to deliver fresh and healthy meals to hospitals, offices, schools or colleges and at home and will be best used for emergency services. Footopter delivers within a long range of 5 kilometers. The traveling speed of this device is 30 kilometers per hour. That is, it can travel 1 kilometer in 2 minutes. That's quite fast. It delivers all products instantly or quickly, but also hygienically. It can be used to deliver medical supplies at a time of emergency, helping senior citizens and children whose parents are at work all day long. As it can deliver all kinds of products besides food too, it is cost effective. During this pandemic of novel coronavirus, no one desires that the products are touched by human hands. That is to avoid spreading of COVID-19. And food opera serves delivery untouched by hands as it uses AI, that is artificial intelligence, to deliver food. Thank you.
Hello everyone, my name is Ashwath and today I am going to present a project on Hyperloop. Hyperloop. So what is Hyperloop? It's a proposed system that uses capsules and tubes to transport goods and people at the speed of 760 mph. Who invented the Hyperloop? That's right. Elon Musk and SpaceX have essentially given off their idea and encouraging others to develop it. How does Hyperloop work? The capsules ride on a bed of air. The pressurized capsules are fired through the tunnels by a combination of linear induction motors and air compressors. In other words, they ride on air. A hyperloop is a proposed type of train that will travel at a very high speed. The reason it can travel so fast is because it is inside a tube with no air. Hyperloop vehicles called pods accelerate gradually and later float along the track using magnetic levitation and glide at high speed for long distances. This is the tube, this is the pod, and this is the control center through which the hyperloop is controlled. This is how it works. Thank you.
My name is Rita and our project is on solar energy. What is solar energy? Solar energy is a radiant light and heat from the sun that is harnessed using a range of ever-evolving technologies.
Is a solar panel? How does a solar panel work? Special panels are used to convert light energy from the sun into electricity. The solar panel absorbs the light or the sunlight from the sun and converts it into electricity that can be used in daily basis. This helps in conserving electricity. But if there is no sunlight or any rechargeable battery, the solar panel can also work through artificial light such as the torch.
Here in my chart, there is a drawing which it is the sun's rays are affecting on the solar panel, and then the solar panel is then from the energy the solar panel over here is giving the energy to EP solar controllers, which is converting the solar energy into normal electricity, and then it is stored in this battery. After the day passes and there is night, it will light up. The light will light up.
Project on solar energy. Facts about solar energy. 173,000 of terabytes of energy consistently strike the earth as solar radiation at any moment, even on the cloudiest days. 1 hour of sunlight is equivalent to 1 year's worth of energy for the planet. Solar energy produces no pollution when generating electricity. Sunlight travels the 90 million miles to Earth in 8 minutes and 20 seconds. Solar power plants can last up to more than 40 years.
The sun has been producing the solar energy for billions of years. It is the most important source of energy in life forms. It is a renewable source of energy. It is a renewable source of energy, unlike non-renewable sources like fossil fuels. Solar technologies use the solar energy of the sun to light homes, heat homes, and produce hot water.
Hello, my name is Albert Einstein. I am a world famous mathematician and a physicist. I was born on 14th March in Germany and raised at a Jeweller's Hold house. My father name is Hermann Einstein and my mother name is Puchilin Koche. My father once gifted me a pocket compass and I started to think about its working. At that time, my interest began in science. I failed to reach the required grades in the general subject, but obedience expectation grades in the physics and mathematics.
I'm going to present a chart on the scientist Julius Robert Mayer. Julius Robert Mayer was born on 20th November 1840 in the city of Heilbronn in Germany. In 1838, he got his doctorate from the University of Thuringia. From 1839 to 1840, he left as a ship's doctor on a Dutch three-mast sailing ship to Jakarta, during which he got interested in the physical phenomenon of heat between stormy waves and the calm sea. In 1840, he received the Knight Cross of the Order of the Crown. In 1841, he got married and had two children. In 1845, he understood that plants convert light energy into chemical energy and that energy can neither be created or destroyed. In 1850, after the death of his two children, he was sent to a mental hospital. In 1869, he was awarded the Prix Consulate, and in 1878, on 20th March, he died.
Hello all, my name is Arman Rathadia. Welcome to Mathoscope 2021. Here you will see implication of maths in real life. So without wasting a single second, let's get started. And now my friend Palash will continue.
I am in class 5A and my class topic is transformation. And today I am going to explain you about this topic. First of all, transformation is divided in three parts. Translation is when the shape moves to a new position without rotating it, reflecting or changing its size. Rotation is when the shape rotates around a vertex which is in one of the corners of a shape while pinning the vertex. Reflection is when the shape is reflected as you see it in a mirror. It is done on a grid with a line called mirror line. Now my friend Shaurya is going to show a project on reflection.
Thank you, Palash. Hi dear friends, parents and teachers. My name is Shaurya Patel. Today I am going to show you a working model on reflection. As you can see, there are two axes, x-axis and y-axis. I am going to show you an example wherein I will show you how is the reflection of one object is seen on the other quadrant. As you can see, there are four quadrants, which are quadrant 1, quadrant 2, quadrant 3 and quadrant 4. There will be a shape in quadrant 1, which is a terminator. Now there will be reflection of quadrant 1's shape in quadrant 2. Now there will be again a reflection of quadrant 1's shape in quadrant 3. And again there will be a reflection of quadrant 1's shape of quadrant 2's shape in quadrant 4. Now my friend Naksh will continue.
Start. Thank you, Shaurya. Now, friends and parents, I am going to explain to you all the definition of reflection and I am going to connect it with real life. Reflection is simply a mirror image of a shape or object. For example, this boy is looking into the water and he sees his reflection. A image reflects through a line. This line is known as the line of reflection. For example, there is a line of reflection between a butterfly. A figure is the reflection of the other part of a figure. Both parts are equal. For example, if you cut an apple into two parts, both parts will be equal and hence they will be same. A reflection should have the same shape, size, but faces in the opposite direction. For example, as you can see here, this boy is looking into the mirror. He sees his reflection with the same size and same shape, but he faces differently. Thank you. Now my friend Dylan will continue.
Hello friends, my name is Dylan and now I am going to show you a working model on translation. This is my quadrant 1 and this is my quadrant 2. Now this pencil, I am going to shift it from my quadrant 1 to my quadrant 2 by translating it. So now I am going to translate my pencil's 4 squares to my right. And now I have translated it to my quadrant. Now I have translated it to my quadrant 2. Thank you. Now my friend Parv is going to continue.
Start.
Thank you, Dylan. Hi, friends and teachers. As Dylan said, I am going to tell you translation in more detail. So, what is translation? In geometry, translation simply means moving. Without rotating, resizing or anything else, just moving. You can see the example below. In the above example, you will see that the triangle ABC is getting translated by just moving it. Not being rotated or resized, just moving. So, friends, now I am going to tell you some real life examples of translation. Some of the examples are a roller coaster, an aircraft, a sewing machine, a slide, and a falling leaf. In a roller coaster, the roller coaster moves continuously from one place to other, which is a translation. In an aircraft, the aircraft continuously changes its place from one area to other, which is again a translation. Thank you. Now my friend Manthan will continue.
Hi friends, my name is Manthan and I am going to show you a working model on rotation. This is my shape and I am going to rotate it 90 degree clockwise. So I rotate it 90 degree clockwise. Now I am going to rotate it 90 degree anti-clockwise. It will look like this. Now if I have to rotate the shape by full rotation, then the shape will look something like this. Thank you. Now my friend Mandini will continue.
Thank you, Manthan. Hello, friends and teachers. My name is Vandani, and today I am going to inform you about rotation in real life. Before knowing rotation in real life, let's know what is rotation. Rotation in mathematics is a concept originating in geometry. Any rotation is a motion of a space that preserves at least one point. That means rotation moves in any clockwise or anti-clockwise. Here are some examples of rotation. A star, the recycle logo, a fidget spinner, a fan, petals on a flower, and pieces of a pizza, and much more. Many people get confused in rotation and translation. Rotation means turning around a center. That means that rotation, the shape moves about 90 degrees at a time. Thank you. Now my friend Vance will continue.
Hello friends and teacher, welcome to the Mathoscope of the year. This year our class 5E will representing you the topic of time. I'm sure you all know what time is in real life, but in maths you may be asking, so hop on in the world of maths and let me explain you what time is in maths. In maths, time can be defined as the ongoing and continuous sequence in duration of events from the past to the present to the future. The measurement of the time began in the ancient Egypt. Egypt invented time prior to 1500 BCE. The time can be measured by various devices. Some of them are the Ghatika Yantra, sundials, a wristwatch, and clocks. Now my friend Mumbai will continue and show you how Ghatika Yantra works.
Thank you, Vansh. Good morning, everybody. Myself, Murmay Sujit Satam. Today I will show you a model of Ghatika Yantra. So, as we know, there were no analog or digital clocks in ancient times. So, how did they measure time? Let me tell you. They made different inventions using various traditional materials and measured time. They even made water clocks. One such water clock was Ghatika Yantra. Here is a water clock. So this is a big brass container and this is a small copper container with a hole in it. As soon as I place the container over here, the water passes through the hole and it starts filling in it. When it is filled, it becomes heavier and bangs down like this. Thank you. Now my friend Samanyu will continue.
Thank you, Murmay. Good morning, all. My name is Samanyu Suvarna. Just now, my partner Murmay had shown you a working model on the Ghatika Yantra. Now, let me give you some more details about this device. The Ghatika Yantra was an ancient water clock which was invented by the Indians to measure time. When they were invented is not known. The Indians divided the day and night into 60 parts called as Ghari. They also divided the night and day into 4 parts called as Prahar. The duration for each ghari is 24 minutes and the duration for each prahar is 3 hours. To measure time using this device, we have to place a vessel with the hole at the bottom on another bigger vessel filled with water. When the vessel with the hole reached the bottom, a gharial was sounded. A gharial was a thick brass disc which was hung at a high place along a mallet. This indicated a certain period of time. In the 7th century BCE, a Chinese traveler had given a detailed account about how this clock works. Now my friend Geet will continue.
Dear my dear teachers, my name is Geet and I will show you how to make a sand clock. So, as you can see, I have taken 2 plastic bottles and attached them together. Before attaching them, I had made holes in both of the bottle caps and then taped them all together. And before taping all of them together, I had put sand inside it and taped it again. And now you can see the sand going in the another bottle. Now my friend Josh will continue.
Thanks, Geet. So, as Geet told, a hourglass or a sand glass, sand timer, sand clock is a device used to measure the passage of time. It comprises 2 glass bulbs connected vertically by a narrow neck that allows regulated flow of substance from the upper bulb to lower one. By the early 14th century, the sand glass was used commonly in Italy. It appears to have been widely used throughout Western Europe from that time through 1500. The first hourglass was invented by a French monk called Liprod in the 8th century AD. Now my friend Anushka will continue.
Thank you, Josh. My name is Anushka Ahmed Gargil, and I am going to present you a model on sundial. So this is the sundial. A sundial is a device that tells us the time of the day when there is sunlight by the apparent position of the sun in the sky. The sundial consists of flat plate, which is also called the dial, and a stick with a wooden piece attached down, which casts shadow on the dial, and we can understand what time it is. Now I will show how the sunlight works. So this is the sunlight. Now I will on my torch and show you how the short shadows are there. So we can see the stick's shadow is moving from 10 a.m. to 11 p.m. and slowly to 12 in the noon. Yeah. And sundial has numbers from 6 in the morning to 6 in the evening. At 6 in the morning, the sun rises, and in the 6 in the evening, it sets. Thank you.
A sundial is a device that tells time of day. It is a noticeable position of the sun in the sky. In 290 BCE, the first sundial, which had been captured in front of the Samanites, also known as the ancient people of Italy, was set up in Rome. It is believed it was invented by Egyptians, Greeks, Roman, or Babylon. In the olden times, the sundial was fixed on a ground made from stone and a wooden stick in the middle. A digital clock uses numbers to show time. The first digital clock was invented by Joseph Paul Weber in 1883 and was known to the world in 1956, October 23rd. It was known as pulsar. Thank you.
Hi, my name is Anupriya. On this beautiful event of Mathoscope, our topic is 3D shapes. My grade 5C has got the shape prism. I will show you some models on prisms. This is a 4-sided prism. This is called a cuboid. This is how its net looks. This is a 5-sided prism. This is how its net looks. This is a 6-sided prism. This is a 7-sided prism. This is how its net looks like. Now my friend Arham will continue.
Yeah. Thank you, Anupriya. Hello, parents. My name is Aram, and today I'm going to show you different types of prisms, its properties, and examples in real life. So, this is a rectangular prism. Its properties are its faces, edges, and vertices, which are 6, 12, and 8 respectively. So, we can see a book as a real life example of rectangular prism. This is a pentagonal prism. We can see its properties are its faces, edges, and vertices, which are 7, 15, and 10 respectively. We can see a house as a real life example of pentagonal prism. This is a hexagonal prism. Its properties are its faces, edges, and vertices, which are 8, 12, and 8, 18, and 12 respectively. We can see pencils as real life example of hexagonal prism. This is a heptagonal prism. Its properties are its faces, edges, and vertices, which are 9, 21, and 14 respectively. We can see an hexagonal prism, heptagonal prism paper model as a real life example of heptagonal prism. Now my friend Neve will continue.
Hi, my name is Neve Sampath, and I am going to tell you something about prism. A prism is a three-dimensional shape having two identical faces. Now I will show you some models of 3D models of prisms. So this is the 8-sided 3D prism, which is the octagonal prism. The net of the octagonal prism is this. If we join all the faces of this net, we get this octagonal prism. This is a anagonal prism, which is a 9-sided prism. The net of the anagonal prism is this. If we join all the faces of the anagonal prism, we get this. This is the 10-sided prism shape, which is the decagonal prism. The net of the decagonal prism is this. If we join all the faces of the net, we get this. Now my friend Shreya will continue.
Thank you, Neve. Friends, now I will tell you the properties of octagonal, nonagonal, and decagonal prism and its real life examples. The octagonal prism has 10 faces which form 16 vertices and 24 edges. Its base shape is octagon and side shape is rectangle. The octagonal prism is a 3D uniform polyhedron. It is the sixth in an infinite set of prisms formed by square sides and two rectangular octagon caps. If faces are all regular, it is a semi-regular polyhedron. Some real-life examples of octagonal prism are this chocolate box, which is also shaped as octagonal prism. This nut and bolt. Maybe you have seen this. You have seen nuts and bolts frequently in your houses. Now, let me tell you about nonagonal prism. This is the real life example of nonagonal prism. It is a drum which is shaped as nonagonal prism. Now let me tell you about the decagonal prism. It has 12 faces and which forms 20 vertices and 30 edges. Its base shape is decagon and side shape is rectangle. Real life example is this. It is a paper shaped decagonal prism. Thank you. Now my friend Arya Rahul will continue.
Thank you, Shreya. Hello, good morning, friends. My name is Arya, and today I am going to give you basic information on pyramids. A pyramid is a type of a shape. There are many kinds of pyramid. Some kinds of pyramid are triangular pyramids, hexagonal pyramids, square-based pyramids, and many more. The pyramids were discovered by King Joseph's architect Imhotep. The first pyramid thing built were the Egyptian pyramids over 4,500 years ago. The word pyramid comes from the Greek word pyramids, which means sweet cake. The ancient word for pyramids was mud. Thank you. Now my friend Maitreyi will continue.
Thank you, Arya. Now, hello friends. Now I'm going to tell you about pentagonal pyramid, hexagonal pyramid, and heptagonal pyramid. A net of a 3D shape means when it is flat open. Similarly, a pentagonal pyramid also has a net. This is a pentagonal pyramid and its net is this. If we join this together, it will form this pyramid. Similarly, this is a hexagonal pyramid and its net is this. Comparably, this is a heptagonal pyramid and its net is this. A pentagonal pyramid has 6 faces, 10 edges and 6 vertices. If we compare this to real life, the best example is a house. A hexagonal pyramid has 7 faces, 12 edges and 7 vertices. If we connect it to real life, there can be a hexagonal based crystal and a temple. A heptagonal pyramid has 8 faces, 14 edges and 8 vertices. If we connect this to real life, a lamp can be an best example of a heptagonal pyramid. Now my friend Pasha will continue.
Hello friends and teachers. My name is Pasha and I have made a model on an octagonal pyramid, nonagonal pyramid and decagonal pyramid. This is an octagonal pyramid. Its net is this. When you fold this all, it becomes like an octagonal base pyramid. This is nonagonal base pyramid and this is its net. When you fold this all, it becomes like an nonagonal base pyramid. This is an decagonal base pyramid. This is its name. When you fold this all, it becomes like a decagonal base pyramid. Thank you. Now my friend Reva will continue.
Hello friends. Today I'm going to talk about octagonal, pentagonal and decagonal pyramids in real life. So, octagonal pyramid. Octagonal pyramid is a pyramid with a base of an octagon. It has 9 edges, 9 faces and 16 vertices. Some examples of octagonal pyramid are reflector,
umbrella, and a ring. Nonagonal pyramid. A nonagonal pyramid is a pyramid with the base of a nonagon. It has 10 edges, 10 faces, and 18 vertices. Some examples of nonagonal pyramids are a research center, and greenhouse reflector, and a house. Decagonal pyramid. Same as nonagonal and octagonal pyramid, a decagonal pyramid has a base of a decagon. It has 11 edges, 11 faces, and 20 vertices. You can see a decagonal pyramid in bottles, umbrellas, and tents. Now my friend Arman will continue.
Life example. Do you know what is this? This is a castle. You may be knowing all of these 3D shapes. It also contains many other shapes besides of prisms and pyramids. Also, you may be recognizing the prisms and pyramids from this castle. Water. As you can see, I'm pouring the citric acid in the beakers of water and I'll make it concentrated with citric acid. Now, I have some baking soda here, which is basic in nature. So I'm going to pour the baking soda into the another beaker, which is going to turn out basic. Now I've poured baking soda and citric acid in both beakers. So I'm going to mix them well. I'm going to mix them nicely so that experiment turns out well. Now I'm going to stir the baking soda and mix it well. So now I'm going to use this instrument and I have a little amount of citric acid into this. As you can see, it is filled. Now I'm going to pour this into baking soda. If you can see closely, there is soda formed here with bubbles. So here we can take this also as an example of clean water and sanitation. Now if I add this full acidic solution into the right, you can see this. So now this water is neutral but not clean and pure because the first question is, which one exists in goals of sustainable development? No poverty, driving the car, watching TV. You have 10 seconds to answer. B.
Your 10 seconds are up. The answer was no poverty. The next question is, list any 3 goals of sustainable development. You have 10 seconds to answer. Your 10 seconds are up. The answer is gender equality, life below water, zero hunger. The next question, which goals means that you need to be healthy and fit? You have 10 seconds to answer.
Could you repeat?
Which goals means that you need to be healthy and fit and should eat protein, mineral, vitamin, etc. Your 10 seconds are up. The answer is zero hunger.
Hello everyone, my name is Shivasmi Mudorkar and I study in grade 6A. Today I'm going to be talking about the aspects of an organic farm. An organic farm is An agriculture system that uses natural and organic inputs while deliberately avoiding the use of synthetic fertilizers. An organic farm is synonymous with sustainable agriculture. An organic farm works in harmony with nature. Major benefits of an organic farm are environmental preservation, economical profitability, social and economical equity, preservation of public health, and most importantly, the conservation of resources, which I'm going to be showing you in this model of mine. So in this model, I'll be explaining compost pit, rainwater harvesting, multi-cropping system, along with these aquaponics system, and also I'll be explaining solar panels and the cow and the animal husbandry. So we'll be starting with the multi-cropping system. So the multi-cropping system is a system which involves growing different types of seeds during the season instead of growing just rabi or kharif crops. This type of system is beneficial as it takes proper care and and makes good use of soil, water, and other natural resources. Also, this can provide food all year long for the people and good money for the farmer. Now we'll be talking about the compost bed. The compost bed contains organic matter like dry leaves and other animal waste and plant waste. This waste is then kept together and is allowed to be mixed in the a deep hole here, and then the compost.
Need of sustainable development. 836 million people still live in extreme poverty. About 1 in 5 persons in developing regions lives on less than $1.25 per day. The overwhelming majority of people living on less than $1.25 a day belong to two regions, Southern Asia and Sub-Saharan Africa. High poverty rates are often found in small, fragile, and conflict-affected countries. 1 in 7 children under age 5 in the world has inadequate height for his or her age. Every day in 2014, 42,000 people had to abandon their homes to seek protection due to conflict. Now my friend Om is going to talk about the goals of sustainable development.
Goals of sustainable development: no poverty, zero hunger, good health and well being, quality education, gender equality, clean water and sanitation.
Is probably the most obvious example of sustainability. Here are three examples. Solar energy. Once the sun's electromagnetic radiation is captured, it produces electricity and heat. Wind energy. Wind turbines convert the kinetic energy in the wind into mechanical power.
Wind energy. People have utilized the power of wind for millennia, dating back to the first recorded windmill in Persia between 500 and 900 AD. Fast forward to the 21st century, and in many localities, energy generated by wind power has become either competitive with or less expensive than coal generated electricity. Solar energy. From rooftop solar panels to massive solar farms that can attain same generating capacity as a conventional power plant, it is clear that there is a renewable energy revolution happening in the world, and it is powered by the sun. Crop rotation. Currently, we produce the bulk of our food through industrial agriculture, a system which relies on large farms that monocrop and use enormous amount of fertilizer and chemical pesticides. Industrial agriculture is immensely damaging to soils, water, air, and the climate. Water efficient fixtures. Many countries in the world are becoming water stressed, and we are beginning to understand that water is not as unlimited as we once believed. In most buildings around the world, essential water usage such as showering, washing hands, and sewage
convenience is unavoidable.
My name is Sanj and this is our project on wind turbines. It is an attempt at showing how energy can be made efficiently and safely. Wind power or wind energy is the use of wind to provide mechanical power through wind turbines to turn electric generators for electrical power. Wind power is a popular, sustainable, renewable source of power that has much smaller impact on the environment compared to burning fossil fuels. Wind is the movement of air from an area of high pressure to an area of low pressure. In fact, wind exists because the sun unevenly heats the surface of the earth. As hot air rises, cooler air moves in to fill the void. As long as the sun shines, the wind will blow. And wind has long served as a power source to humans. Ancient mariners used sails to capture the wind. Farmers once used windmills to grind their grains and pump water. Today, more and more wind turbines bring electricity from air breeze. Over the past decade, wind turbine use has increased more than 25% per year. Still, it only provides a small fraction of the world's energy. The biggest wind turbines generate enough electricity in a year, about 12 megawatt hours, to supply about 600 US homes. Wind farms have tens and sometimes thousands of these turbines lined up together in particularly windy spots. Smaller turbines erected in a backyard can produce enough electricity for a single home or small business. Drawbacks include complaints from locals that wind turbines are ugly and noisy. The slowly rotating blades can also kill birds and bats, but not nearly as many as power lines, and high-rise buildings do. The wind is also variable. If it's not blowing, there is no electricity generated. Nevertheless, the wind energy industry is booming. Thanks to global efforts to combat climate change, such as the Paris Agreement, renewable energy is seeing a boom in growth, with wind energy leading the way. From 2000 to 2015, cumulative wind capacity around the world has increased from 17,000 megawatts to more than 430,000 megawatts. Industry experts predict that if this pace growth continues, by 2050, one-third of the world's electricity needs will be fulfilled by wind power. This model, which we have made, shows a small wind turbine with a fan and a dynamo which generates electricity through mechanical energy. Wires and cables pass through, and inside the house there is an LED bulb which lights up due to the electricity produced by the dynamo. This was to show how the wind turbine works. As you saw that when this blade rotated, the light inside the house lighted up.
Come on. Today we are going to introduce you to a very interesting game called the Board of Numbers.
Hello all. So today we will show you how to play this game. In this game you require a dice. You roll your dice and the number I got was 6. Gunjan will go 6 steps ahead on the board now. I roll my dice again and the number I get is the difficulty level of my question. The number came as 1. Now Gunjan will ask me a question.
So the question is, what is the value of a pi?
The value of a pi is 3.14. If I get my answer correct, my difficulty level is the number of steps I go ahead.
So the
my
step is
level is 1, so I go ahead 1 step.
So the cost price I have got 60.
So
So Anna's cost price is 60, so I write here 60. And the selling price is 85. And her selling price is 85. So here she is in profit with 25. So simply what we will do is whatever is the profit we will write on the top. So it is 25. So it is 25 upon 60 into 100, which is nothing but 41.67. So Anna, we go with the round number 2. Yeah. So for cost price I got 15. 15. And Anna's cost price is 15. And let's see in our last deal does she go in profit? And for the selling price I got 35. 35 again in a profit. So she is in profit with 20 here. Good afternoon. We will be doing 3 deals with you. You and give points according to the profit and loss in your deals. The person with the most profit wins. One deal equals one chance, and you have to solve the profit percentage or loss percentage according to the cost price or selling price you get. The formula is shown on Palak's screen, so take a moment to look at it. So here first we'll go Arnavi. So Arnavi will pick chits from our boxes. So the cost price I've got 60. So Arnavi's cost price is 60. So I write here 60. And the selling price is 85. And her selling price is 85. So here she is in profit with 25. So simply what we will do is whatever is the profit we will write on the top. So it is 25. So it is 25 upon 60 into 100, which is nothing but 41.67. So Anna, we go with the round number 2. Yeah. So for cost price I got 15. 15. And Anna's cost price is 15. And let's see in our last deal does she go in profit? And for the selling price I got 35. 35 again in a profit. So she is in profit with 20 here. So 20 upon 15 into 100, which is nothing but 133.33. So now we will add her both the points and we will see what is the total. So Arnavi, stay tuned to know your points. And your total points are 175. So you have no profit in both the deals. You have no loss in both the deals. You have profit. So congrats, your point, total points are 175. Yeah, so only this much. Thank you.
Alert, alert, alert. Heer, Shant, Shubham, Heath, and myself, Karistha, together Team Factopedia, are here to tell you all about our number friend Zero. Here is a little gist about how Zero actually came into existence with a little fictitious twist of our own.
Upon a time, zero wasn't really a number. Its journey to a full-fledged number we know and love today is a meandering one.
Today, zero is both a placeholder and a tool within a number system, but it wasn't always.
Initially, there were only 9 numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9.
Zero wasn't into picture yet because each civilization had its own theory on how to indicate an increase in numbers, like Greeks and Egyptians used patterns.
Today, thanks to Aryabhatta or say India, Aryabhatta was a mathematician astronomer from the classical Indian age, the Gupta Empire.
He introduced Zero and how to implement it and see how simple everything now has become. Now our team will present a video.
Zero presented you by Team Factopedia with a little fictitious twist. In the vast universe, there was a planet named the Numberland. Well, all of the numbers lived there peacefully. Did you expect them to live peacefully? No, because they did not. They always had an argument considering who was the highest valued number. Generally, 9 was considered as the highest valued number among all of the others. Well, you're wondering where 0 is? It wasn't even taken into consideration. All the other numbers mocked at 0, telling how worthless and useless he was. But 0 was always determined to show everybody that he too had worth like every other number did. After pondering for ages, 0 finally found a solution. It was simply by placing itself before the actual digit to indicate an increase in the number.
Hello everyone, this is Samriti and that's my friend Siddhi, and today we'll be presenting to you the basics of trigonometry.
So let's have a look at this model. Between the house and a tree, a right angle triangle is formed with this as the base, this as the height, and this as the hypotenuse side. Did you know that the hypotenuse is the longest side of a right angle triangle, and the angle formed between it and the base is called theta?
Now let's learn something about the word trigonometry. The word is divided into two parts, trigno and metry, which means triangle and measure respectively. So trigonometry simply means measures of a triangle. For example, if the lengths of two sides of a triangle and measure of an angle are known, the third side can be calculated.
Now that we know what trigonometry is, let's see three equations that can be used to find the sides of this triangle by using theta. This is the first function that is sine. It is height upon hypotenuse. The next one is cosine or the cos, which is base upon hypotenuse. The next one is tangent, which is height upon base.
Lastly, let's see the application of trigonometry. Some of the examples of it are finding the height of a mountain and finding the height of a building. Thank you.
Good morning. My name is Tia.
Good morning, my name is Aryan.
Today we will be taking you to the world of bar graphs and that too one that works. Now my friend Aryan will tell you about the bar graph.
A bar graph or a bar chart is a graph that represents categorical data with heights or lengths that are proportional to the values that they represent. A bar chart can either be horizontal or vertical. A vertical bar chart is sometimes called a column chart. Want to know more about a bar chart? Now my friend Tia will tell you about it.
A graph can be defined as a chart or graphical representation of data using quantities or numbers using strips. They are used to compare and contrast numbers or other measures of distinct categories of data. There must be an independent variable and a dependent variable. In this case, the horizontal axis belongs to the independent variable and the vertical axis belongs to the dependent variable. I will be taking an example of the monthly active users of selected social media networks and messaging services. 2,498 million people use Facebook. While 2,000 million people use YouTube and WhatsApp.
1,000 million people use Instagram. Twitter is used only by 386 million people. And Snapchat is used by 398 million people. As you can see, Facebook dominates the social media landscape. Thank you.
Hello everyone, my name is Riya Gube and today my friend Sanvi and I are going to present you a project about tessellations. So, tessellations are geometrical patterns which do not have any spaces between them and the angles at the point where these shapes meet add up to 360 degrees. Various polygons tessellate and I am going to show you a few of these polygons tessellate. So let's start up with a tessellation of triangles. We'll arrange 4 of the triangles over here on this sheet.
When we look deep into the history, we can see that various Roman and Islamic monuments used tessellating patterns for tiling in the 20th century. M.C. Escher, an architect, invented tessellations and used it for various kinds of architecture for an artistic effect. Johannes Kepler observed the tessellations in nature and documented his study in his book. Snowflakes and honeycombs are some examples of tessellating patterns present in nature. Some modern-day examples include the Gherkin in London is a cucumber-shaped skyscraper composed of various tessellations. Palma Nova, an Italian city, is located in a fort which tessellates it to form a star-like structure.
Thank you.
Good morning, everyone. Today, me and my friend Vidhi are going to present about Pythagoras theorem. The Pythagoras theorem states that the square of the hypotenuse is equal to the sum of squares of the other two sides. In this triangle, the sides are the perpendicular, the base, and the hypotenuse, where the hypotenuse is the longest side because it is opposite to the 90 degrees. You can use the Pythagoras theorem for two-dimensional navigation. You can use it and the other two sides to find the shortest distance. Now my friend Vidhi will continue.
How to find the hypotenuse of a right angle triangle? To find the hypotenuse, the formula is a square plus b square is equals to c square. Let me give you an example. The base is a square. The height is b square. And the hypotenuse is the c square. Now, the length of the base is 3 centimeters. The length of the height is 4 centimeters. So now, let's replace the numbers with the formula. So, a square plus b square is equals to c square becomes 3 square plus 4 square is equals to c square. Square the numbers and it will become 9 plus 16 is equals to c square. Put the square sign on the other side. It will become square root. So 25 square root is equals to c. 5 is equals to c. Therefore, the answer is 5 centimeters. Thank you.
Good morning. Today we are going to present you a model on area of a circle.
Area of a circle is the region occupied by the circle in a two-dimensional plane. It can be determined easily using a formula. Area is equal to pi r square, where r is the radius of the circle. The unit of area is the square unit, such as meter square, centimeter square, etc. Pi is an irrational number with a value of approximately 3.1415926.
Radius is any line segment from the center to its perimeter, and in even more modern language, it is their length. The word radius comes from a Latin word which means ray.
As you can see, when we cut a circle into many pieces and arrange it in the way my friend Ishika is showing, it slowly turns out to a rectangle. As we all know that the formula for finding area of a rectangle is length into breadth, so by referring to the rectangle Ishika is showing, the length is pi r and the breadth is r, and which is pi r square.
Good morning, everyone. Today, my friend Vyoma and I are going to present about enlargement. What is enlargement? Enlargement is an example of a transformation. A transformation is a way of changing the size or position of a shape. Enlarging a shape changes its size. All sides of the triangle are twice as long as the sides of the original triangle.
So as my friend Vinisha explained what is enlargement, I'm going to explain the steps. To enlarge a shape, a center of enlargement is highly required. Like here, the center of enlargement is O. When a shape is enlarged from the center of enlargement, the distance from center to each point are multiplied by the scale factor. For example, if the scale factor can be 2, or sometimes it can be 3 or 4 or so on.
So, as my friend Vyoma said, in this graph, you have to enlarge the purple triangle ABC by the scale factor 2 about the center of enlargement, which is O right here.
So for the answer, first you have to draw the ray lines from O to each vertex of the triangle and extend them. So here I have a red thread to explain you all. So this is the center of enlargement, which is O, as I told you all. We will extend it, and there you have your ray of light. We'll do the same for all the vertices. Multiply by distance, like the scale factor by 2, and plot the points P, Q, R. So now when you point it, you have to name each vertex. Here I have done it ABC, but my friend Tanisha has done PQR.
Good afternoon, teachers. Today, me and my friend are going to show you a project that we've done on symmetry.
Some of you may have learned about symmetry, but we are here to give you a better concept, a simpler and shorter concept on symmetry.
What is symmetry? Symmetry defines that one half of a shape is exactly like the other half when it is moved. Images that can be divided into identical halves are known to be symmetrical. As you can see, this leaf is symmetrical because the two sides are like mirror reflections. Symmetry can either be bilateral, as you can see in this spoon, or radial, as you can see in this ball, or asymmetrical, as you can see in this feather. What is the line of symmetry? A line that cuts a shape exactly in half such that they match each other perfectly is known as the line of symmetry. Examples B, C, H, and D. You can see this diagram here of the letter B and this red line which cuts it in equal halves. This red line is the line of symmetry.
In the 3D shapes, we don't have the line of symmetry while we have planes of symmetry. Like this cuboid, it has 3 planes of symmetry. And a cylinder which has infinite planes of symmetry. Then we have a cube which has 9 planes of symmetry.
The cube has 9 planes of symmetry. 3 planes lie parallel to each other, as you can see here, and 6 planes which are opposite to each other, excepting these two which are diagonal. Thank you.
When we look deep into the history, we can see that various Roman and Islamic monuments used tessellating patterns for tiling in the 20th century. M.C. Escher, an architect, invented tessellations and used it for various kinds of architecture for an artistic effect. Johannes Kepler observed the tessellations in nature and documented his study in his book. Snowflakes and honeycombs are some examples of tessellating patterns present in nature. Some modern day examples include the Gherkin in London is a cucumber-shaped skyscraper composed of various tessellations. Palmanova, an Italian city, is located in a fort which tessellates it to form a star-like structure.
Thank you.
My project for the scintillation is an air cooler. The materials you need for this is a jar, a small fan, a DC motor, battery cells, some ice cubes, a hot glue gun, and some wires. So how this works is you have to put some ice cubes for some ventilation and cooling. There is an LED to show that the lights are working. The basic working principle of the air cooler is by water evaporation to cool the air, which it absorbs the heat energy and lowers the air temperature.
Guys, today I and my friends are going to present you a science project known as water dispenser, and the materials which are used in this are a cardboard, a glass, a bottle, and some tubes. And here you can see like when we open the glass bottle, when we open the tube, so the water flows out of the bottle. Now my friend Par will let you know the science behind this.
Show how the solar farm works. This is borewell which contains water. This is pipe which transports the water from borewell via a motor to the sprinkler. This is farm which contains grass and plants. This is the sprinkler which sprinkle the water all around the farms rotating clockwise. This is solar house which has two solar panels and an inverter which works the motor to sprinkle the water in the farms.
Friends are going to present a model on days of dates. A common problem with finding the days of dates is faced by many of us in everyday life. An easy yet efficient method of finding days of dates is simply brought in this model. Now my friend Bhavya and Daira will continue.
Let's see how to go about this. First, we have to write the date in this row. The date should specifically include the date, the month, and the year. Now we'll take the date as 7th June 2006. Now let's see how to fill these boxes. To fill the first box, you simply need to copy down the date, which is 7. To fill the second box, we'll have to refer to this month code. This is a 12-digit month code. To remember this month code, we have found a simple technique. Just divide the 12 digits in 4 groups of 3 each. The first group is the square of 12, 144. The second is the square of 5, which is 25. The third group is the square of 6, which is 36. And the fourth group is simply 146. Here we've taken the month as June, which is the 6th month. So the 6th digit from the left here is 5. So we'll write 5 in the second box. To fill the third box, we'll need this century code. This century code is simply a sequence of 0, 6, 4, and 2. The years 1500 to 2099 is listed here. If you want to find out the codes of any other centuries, you can simply follow the sequence of 0, 6, 4, and 2. Calculate the number of leap years by dividing the year number by 4. So here you get the answer as 1. Then you have to sum up all the numbers in your 5 boxes. When you sum these numbers, you get the answer as 25. When you get the sum, you have to divide the number by 7. This is because there are 7 days in a week. When you divide 25 by 7, you get the remainder as 4. Remember to take the remainder to get the day. Then you have to use this day code. We get the remainder as 4. So here 4 is the code for Wednesday. Therefore 7th June 2006 was a Wednesday. Thank you.
Calculating numbers sometimes can get very difficult, especially if they're long. But now there's no need of those time-consuming calculations anymore. There's a formula for that. It is called formula for sum of n, which is natural numbers. So the formula goes like this. N bracket n plus 1 the whole upon 2.
So there's an example of how it works. So it's 1 plus 2, 3 plus 4 plus 5. So it'll go like 5 bracket 5 plus 1, the whole upon 2. So it is 5 into 6 upon 2, which will give you 30 upon 2, and the answer you get would be 15.
Good morning, everyone. Today we are going to talk about Hooper's paradox. So let's see where this came from first. So Hooper's paradox is a falsistical paradox based on an optical illusion. William Hooper published the paradox 1774 in his book Rational Recreations, in which he named it the geometric money. However, Hooper was not the first one to publish this geometric fallacy. So what exactly is the illusion about? As you can see, this set of 4 pieces is called Hooper's paradox. The top rectangle has an area of 30 and can be rearranged into the bottom shape, which is made up of 2 rectangles. Strangely, these 2 rectangles have a combined area of 32. So what I mean to say is the paradox is mean that the rearrangement of the same figures has 2 different areas. Thus, an area of 30 square units is being transformed into 32 by mere cutting and rearrangement of the pieces. Hooper's paradox can be given an infinite number of forms by varying the proportions of the figures and the degree of slope of the diagonal. It can be constructed so that the loss and gain is 1 square unit, 2, 3, 4, 5, and so on upon to infinity. Obviously, the smaller the difference, the more difficult it is to detect the deceiving number of the construction. So, upon close inspection, one can notice that the triangles of the dissected shape are not identical to the triangles in the rectangle. I mean, the rectangle with the area of 30 has different triangles from the other one, yet similar. The length of the shorter side at the right angle measures 2 units in the original shape, but only 1.8 units in the rectangle. This means the real triangles of the original shape overlap in the rectangle. The overlapping area is a parallelogram, the diagonals and sides of which can be computed via the Pascal's theorem. As you can see in the right-hand side diagram, the brown area is the parallelogram, where the overlapping area can be computed. So the area of this parallelogram can be determined using Heron's formula for the triangles. This yields for the half circumference of the triangle, and with that, the area of the parallelogram. So the overlapping area accounts for 1:2 units. And thus, the paradox states that the 2 different areas was because of the overlapped parallelogram. Thank you.
I will be presenting to you a mathematical experiment. Let us get started. When we think of pi, we think of something related to the circumference of a circle or shapes and geometry. Little do we know that pi is everywhere. To prove this, I'm going to be doing an experiment, and the name of this experiment is Buffon's needle experiment. Let us get started. For this experiment, I will be using a cardboard sheet, a calculator and some rod-like or stick-like figures. I will be using about 190 of these. Please note that the greater the number of sticks that I use, the higher the accuracy I will be able to obtain. Now, let us consider that the length of every stick in this box is about 1 unit, and the distance between the parallel lines that I have drawn over here is about 2 units. Now, I will randomly drop these sticks onto my cardboard sheet and spread them out in such a manner that they do not overlap each other. Please remember that this is a completely random process. Now, I will be counting the number of sticks that have crossed the 3 lines that I drew earlier. Now, so the number of sticks that have crossed the line are about 61. Now, using this formula, which states that I have to divide the number of sticks used by the number of sticks that crossed my line, I will be able to obtain a value of 3.114 and so on, which means that I was able to obtain the value of pi to two significant figures using a completely random process. Now, that's intriguing, isn't it? Let us understand the maths behind this. To understand what is happening here, we need to know that this experiment is commonly known as Buffon's needle problem. It was found out by a French naturalist in the 18th century known as Comte de Buffon. While conducting this experiment, the question he asked was, what is the probability a needle crosses a line? Well, to answer that, I have randomly placed a rod onto my between two of these lines. I will be focusing on its middle point, as you can see, as a reference. Now, I can say that this part is half because the entire length of my rod is 1 unit. I can define D as the distance between the middle of the needle to the closest horizontal line. I can define theta as the acute angle between the needle and the horizontal lines. Now, let us talk about the range of our two variables. So, I know that D will lie between 0 and 1. 1 because the at most value D can be because of this, which will be the half of my the distance between my two parallel lines, which is about 1 unit. So D will be between 0 and 1. Theta will be between 0 or 90 degree, and another way to say 90 degree is pi by 2. So I can say that theta is between 0 or 0 and pi by 2. But now we come to an important question which says, what are the conditions that will ensure that my rod will intersect? Well, let us see. If I say that theta lies between 0 and pi by 2, well, let's go here and say it's 90 degree. So yes, it will enable my enable my rod to intersect. So this condition is valid. Yet, let's say my stick was placed like this, and here my rod is having a value of between 0 and 1. My value of D will not be between 0 and 1 while if I want my stick to intersect. Now, what to do? Well, let's come back over here. If you notice carefully, we can determine this value. How? Well, this is where trigonometry comes into the picture. Using the sine, we can figure out that O is half sine theta. So now I know that this value should be greater than my D for my rod to cross the line. So if my half sine theta was greater than D, I will be able to cross my line. So that gives me another condition which tells me half sine theta should be greater than or equal to D to enable my rod to intersect. Now, I've drawn a graph to represent the relation between D and theta. These two variables enable me to draw a graph such as this, and I have used their ranges over here, define my axes, and this is the graph that forms. Now I can say that the probability that my line will intersect will be the area under the curve divided by the area of rectangle. So the area under the curve divided by the area of rectangle will enable me to obtain the value of the probability that my rod will intersect. Well, to calculate this, we will be using we will be using calculus. Well, as you can see over here, I can find out the area of my shaded region by doing this integral of and I get the value of half. Then I will simply remove the area of my rectangle, which is 1 into pi by 2, which is pi by 2. Then using this formula, which is area under curve divided by area of rectangle, I can say 1 by 2 divided by pi by 2, 1 by pi by 2, which will give me the value of 1 by pi, which is using pi as a constant. So isn't it interesting to see how pi will be used as a constant in this experiment? Now let us get back to our experiment. I know that the X are the successes, which is about 61. Please forgive this mishap I did over here. So it's about 61 successes that I got, and N will be the number of tosses, which is the number of sticks or rods that I used, which is 190. So when I say X by N should give me, using this previously done calculations, I can say it should give me 1 by pi. Thus, I will take the reciprocal and I will get N divided by X, which is number of tosses divided by successes, should give me pi. So you see, I know that when the size of my rod is half of that of the distance between the parallel lines, I know that N divided by X will give me pi, which was 190 divided by 61 will give me the value of pi. That is how I was able to obtain the value of pi correct to some degree. This is only one of the proofs that have been gathered for this experiment. For more details, you can search about Barbier's proof, which is another way to understand how this problem works. Thank you.
So here I have a simulation created by the University of Illinois, and here I can show you how I can increase the number of needles that were dropped to get a more accuracy. So here, when I drop about 1,000 of these needles, I will be able to get a value of 3.142. If you can see that, then let's increase this value. So let's say 3,000, and I get a little more accurate, and so on. So as you can see, the more number of needles that I have, the more accurate the number of value of pi I will be able to obtain. So, yep.
Greetings everyone. My name is Vansh Patel and I'm a student in the first year of IB Diploma program. Today on the occasion of DPJ Mathoscope 2021, I'm going to present to you a mind-bending paradox. So, let's get started. This is Zeno of Elea, an ancient Greek philosopher famous for inventing a number of paradoxes, arguments that seem logical but whose conclusion is contradictory or absurd. For more than 2000 years, Zeno's extremely challenging riddles have inspired mathematicians and philosophers to better understand the nature of infinity. One of the best known of Zeno's paradox is called the dichotomy paradox, which means the paradox of cutting in two in ancient Greek. It goes something like this. After a long day of sitting around thinking, Zeno decides to take a walk from his house to the park. The fresh air clears his mind and helps him think better. In order to get to the park, he first has to get to halfway to the park. This portion of his journey takes some finite amount of time. Once he gets the halfway point, he needs to walk half the remaining distance. Again, this takes a finite amount of time. Once he gets there, he still needs to walk half the distance that's left, which again takes another finite amount of time. This happens again and again and again. You can see that we can keep going like this forever, dividing whatever distance is left into smaller and smaller pieces, each of which takes some finite time to traverse. So, how long does it take Zeno to get to the park? Well, to find out, you need to add the times of each of the pieces of the journey. The problem is, there are infinitely many of these finite sized pieces. So, shouldn't the total time be infinity? According to this argument, traveling from one location to any other location should take an infinite amount of time. In other words, it says that all motion is impossible. The conclusion is clearly absurd. But where's the flaw in the logic? To resolve the paradox, it helps to turn the story into a mathematics problem. Let's suppose that Zeno's house is 1 mile from the park and that Zeno walks at 1 mile per hour. Common sense tells us that the time for the journey should be 1 hour. But let's look at things from Zeno's point of view and divide up the journey into pieces. The first half of the journey takes half an hour, the next part takes quarter of an hour, the third part takes an eighth of an hour, and so on. Summing up all these times, we get a series that looks like this. Now Zeno might say, since there are infinitely many of terms on the right side of the equation, and each individual term is finite, the sum should equal infinity, right? That is the problem of Zeno's argument. As mathematicians have since realized, it is possible to add up infinitely many finite sized terms and still get a finite answer. How, you ask? Well, let's think of it as this way. Let's start with a square that has an area of 1 meter square. Now let's chop the square in half and then chop the remaining half in half and so on. While we are doing this, let's keep track of the area of the pieces too. The first slice makes two parts, each with an area of 1/2. The next slice divides one of these halves in half, and so on. But no matter how many times we slice up the boxes, the total area is still the sum of the areas of all the pieces. Now you can see why we chose this particular way of cutting up the square. We've obtained the same infinite series as we had for the time of Zeno's journey. As we construct more and more blue pieces, to use the math jargon, we take the limit as n tends to infinity. The entire square becomes covered with blue. But the area of square is still just one unit, and so the infinite sum must equal 1. Going back to Zeno's journey, we can now see how the paradox is resolved. Not only does the infinite series sum to a finite answer, but that finite answer is the same as the one that common sense tells us is true. Zeno's journey takes 1 hour. Thank you everyone. Hope you all enjoyed the presentation.